Hi everyone, just going to show you how to do this Excel correlation and regression exercise. Now in this one I've asked you to do two things. The first one is, if you haven't already done it, I need you to go install the Data Analysis Toolpak. I show that in the assignment itself, or on Canvas for this assignment, but also here. And I've put a video on both how to install it for a PC and a Mac. I'm going to show you right now on a PC. Both of these videos are less than a minute and are very easy. And then I've got a screenshot here for a Mac on going to Tools, Add-ins, and then clicking on both the Analysis Toolpak and the Solver add-in. You're going to know if you've installed it when you go up to Data up here, if all the way here on the right on the ribbon you have an Analyze and it says Data Analysis, that's the Toolpak, and Solver. If these aren't showing up, then you need to install them. Okay. On a PC, what you do is you go here to File, all the way down to Options, okay, then all the way down here to Add-ins, and then you can see I've already got it installed, but if you just go down here to Manage and hit Go, I've already selected all four of these. You may or may not need the zero currency tool, but please select all of the others. So in fact, just do all four. Okay, and then if you do, then this will show up over here on the data drop down or data menu all the way over here on the far right of the ribbon. Okay, we're going to need that to be able to run a regression. Okay, the other thing is that I asked you to watch this video here. It starts off with this woman here about correlation and bivariate data. It's a 12-minute video, and you can stop here. I think the captions or the stuff at the end, the credits roll at about 11 minutes and 40 seconds. It's quite well done, and it is going to explain about the correlation line and what a correlation is. It has nice definitions, and you can watch it at double speed. So I'm not going to be able to cover everything about correlation, but if you watch this, it will give you quite a bit of information that you'll need in doing this video. Okay. Now if I go back, to the spreadsheet, I'm going to talk here really quickly about correlations, and then what we're going to do is we're going to do a number of things here with this data around the Ann Arbor rental market and plotting the relationship between square footage and monthly rent. Okay, so correlation, as I wrote here, a correlation is essentially how accurately does movement in one variable predict the corresponding movement in another variable. Okay, and then we measure it with something called this correlation coefficient that I bolded over here for the vocabulary. It's pronounced R and sometimes rho, which is the Greek letter. It's the Greek letter R. I'm going to use R because then as we'll see, it's related to something called R squared. It ranges from -1 to a +1, and it captures, as I put here, both the direction and the strength of the relationship between two variables. Okay, and then if you look over here, if it is close to +1, that indicates, in fact, 1 means it's a straight line. This is a straight line, and this is a strong positive correlation, and this one over here would be a -1. Okay, and something here in the middle, or like what I've got right here, this would be no correlation. Okay, right? This would be that there is a very, very weak or no correlation. Okay, and of course in life we never see anything exactly that strong. But I wanted you to see this is what they'll look like. You've got a strong positive correlation, a weak positive, a strong negative, a weak negative. People tend to use a cutoff of about 0.7, but in practice, as between weak and strong. But in practice, normally what you're looking at is you're going to plot the data and just kind of look at, does it seem like there is a strong correlation? Nothing is going to be straight on this line. Okay, I'm going to show you how to do it in Excel in just a moment. Okay, but if we were to look down here, and you'll want to pay attention to this, I'm going to ask you a question on the quiz to sort of label these, right? So if I give you 4 correlation coefficients, 2 of them are positive, a 0.65 and a 0.84, and then you've got a -0.02 and a -0.72. And then if I asked you to match which to which, the first thing I would try and do is say which ones have positive correlations, which look like B and D, and then which one has a negative correlation that looks like A, and then scatterplot C kind of looks like these two here where there's no correlation. And that in fact is C is the one that has the negative 0.02. Okay, and then the increase in the correlation coefficient, if you look at this over here, it can be a little misleading because sometimes people say, oh, it's because it's steeper. But the reason is that this is a stronger correlation than this one in the middle is because the points are closer to the line, not that it is steeper. Okay, so if we look down here, I think we can see, look, the points are closer to the line here on scatterplot B than they are on D. So this would be a stronger positive correlation. So this is a 0.84 and this is a 0.65, positive 0.65. Okay, so that is our correlation coefficient. Okay, now it always goes to point out correlation does not equal causation. And I've put some spurious correlations here. In fact, there is a website by this Tyler Vegan called Spurious Correlations that I'll pull up. Lots of people pull this. And in fact, a lot of people like to use this Nicolas Cage one right here. And she uses it in the video about correlation between Nicolas Cage movies and number of people who drown in a pool. Okay. Or per capita cheese consumption, a number of people who died becoming tangled in their bed sheets. And this is a point, like this is a 94 point. If you can see in there, I'm going to go ahead and actually zoom in. You can see that the R, the correlation coefficient, is 0.947. So this looks like to be a strong relationship, even though obviously that's just a coincidence. Like there's nothing, there's no reason that cheese consumption is predicting number of people who die this way, which is a horrible thing to think about. But I wanted you, this is a very common thing often, and we need to remember it, is that correlation does not imply causation. Okay, so let's go back to here. So we've installed the Toolpak. This is what correlation means. We want to be careful about spurious correlations. And then where we get to the meat of this is here on this Arbor Rental. So I've collected data. This is 40 rentals. This is now getting a little bit dated, but these are apartments all within a 6 block by 6 block quadrant north of the University of Michigan campus, where I went to school. Now these prices are a lot more expensive, I'm sure, but I grabbed the data around the number of bedrooms, the number of bathrooms, and the rent for these apartments. Okay, and then in column D, I have the square footage. I have pasted column E right next to it to make it easier for us to do our scatter plot. And then I want to show you what happens when we put square footage in thousands. So I just put it here where I divided it by 1,000. Okay. Now I'm going to go ahead and slide these over to the right. And I'm going to do the scatter plot first, and then I'm going to come back and show you this correlation. But you'll need to do both. Okay. So the easiest way to do a scatter plot is I'm going to go up here to D1, and then I'm going to shift right click over so that I have square footage and rent. This is the fastest and easiest way to do a scatter plot. And then I'm going to do Control Shift down on a PC or Command Shift down on a Mac. And now I'm going to go to Insert. Okay, on a PC it's this one right here, which is the scatter plot. On a Mac, it might be the same, but it might be right here, or you can click on Recommended Charts. And then we'll go down to this XY scatter, and we want this one right here, the one with the blue dots. Okay. Let me show that again. So I go to Insert. I've selected these two columns, columns D as in David and E as in Echo. Now in this case, I'm going to just click right here and click this scatter plot. Okay, and a scatter plot is a nice plot that shows the relationship between two variables. Or plots, sometimes things aren't related, but it's going to plot them here, right? And so what we want here, I'm going to label this right now, and we'll add some nice design. And then so I'm going to call this as correlation between square footage and monthly rent. So that's my title. I'm going to click here, and now I can go up and bold this. Okay. Now I'm going to go ahead and add, I want to always label my axes. So this is my x-axis and my y-axis. There's two ways you can do it. If you've selected on the chart, you can click this plus, and then we'll put the axis titles. Or I can click on the chart, and you'll notice when I do it, it highlights. So if I click off, it goes away up here. But if I click back on this chart, it now gives me these chart tools for design and format. And if I go to design, I can add a chart element, and then go down to axis titles, and we'll end up adding both of them, both this and the vertical one. Okay, so I'm going to go ahead and click the plus because I can do both. So on this one, I double clicked, and I'm now going to call it square footage. I'll click off, and then if I click back on it, I can treat it like a text box and say if I wanted to bold it, or if I wanted to increase the the font size. I'm going to leave that at 11, and then I'm going to click here on this one. And when on the vertical axis, on the y-axis, when I want to edit, I can start typing. I find it easier to type in this formula bar, and I'm just going to type monthly rent. Okay, and again, I'll do bold and increase it. Okay, so now I've got this correlation or the relationship between square footage and monthly rent. This is Ann Arbor. I'm going to get rid of this vertical line, so I'm clicking on the vertical lines, and then I'm going to hit delete just to clean it up a little bit. I could delete these horizontal lines, but I'm going to leave it in. Okay, so I've created this scatter plot with square footage, where square footage I want on the x-axis, and then I want rent on the vertical axis. And by tradition, what we normally think of is this one on the x-axis is called the predictor, or it's a predictor variable. Sometimes they're called independent variables. Okay, and then we assume that the one on the x-axis is causing, or that's what our hypothesis is that the one on the x-axis is causing the one on the vertical axis or the y-axis. Okay, so if you get this reversed, or you want to make sure that the one with the dollar signs, that's why I kind of labeled this, is that it would show up that the dollar signs are here on the vertical axis and the square footage is on the x-axis. Okay. Now, this is where the cool stuff happens, which is that now we want to add the trend line, the equation, and the R squared to the scatter plot. So let me click up here. Actually, let me put on a border around this. So I'm going to go to shape outline. I just find it a little bit easier if I have a line marking its borders. And then I'm going to drag it down just because in a minute we're going to put the correlation up here in H3 and the R squared in H4. Okay. Now this is or what we want to end up doing here is I want to right click on one of these dots. Doesn't matter which one, but I want to right click on it. And then what you'll see is it says add trend line right there. So again, I'm going to click off. I'm going to right click on one of these dots, add a trend line. And when you do that, it's going to pop open this window over here. Okay. Now on mine, I've got it kind of shrunk down so I can see display equation and R squared on my window. I find for most student ones, you end up having to scroll down. This will be kind of below here, and there will be a scroll, like I've got to scroll down here, and there will be another one over here on the right. The other thing is to make sure that this is checked as linear. In more advanced classes or further down the road, we can check a polynomial, which is how you start fitting curves. But we just want to stick with a straight line right now. Okay? And so what we want to end up doing is I want to click on display equation on the chart and then display the R squared on the chart. And you'll notice this has popped up right here. Okay? So I'm going to go ahead and do that again. And if I want to get rid of the trend line, the easiest way is click on the trend line and then just hit delete. Okay, so I'm going to right click on any of these dots, add the trend line, and then what I want to do is display the equation and the r squared on the chart. So it should add this line. If we wanted to, I could click over here and change something about the color and how thick this line is. I'm just going to leave it as this dotted blue line. Okay, I am going to move this data. This is a text box. I can move it, and I'm going to go ahead and bold it and click it up to be one size. In fact, I'll click it up to be two sizes because I want to make sure everybody can see what I'm doing here. In fact, I'll zoom in here a little bit. Okay, so what we've actually done, this is a regression line. This is a linear regression line. And this is also how, on the correlation tab, these lines would be drawn. Okay, so this is called the regression line. Sometimes it's called the line of least squares, or this is called ordinary least squares regression. You'll get into that in your statistics class. For us, all we need to think about is it is the line of best fit. So on average, it's going to be the closest to it. It minimizes the distance from all of these points. Like it adds up the distance from all these points. And is finding the line of best fit. Okay. Now, if we look over here, the other thing you'll notice is it looks like we have an outlier. So there is I've highlighted it in yellow, but this one that has 4,319 square feet looks like there is a house included in the data that should not be. So now we could delete it, and this line would actually fit much better. And this is called an influential point or an outlier. And there's often different ways to include it. I'm going to include it, and I have included it because this is very common to happen in data. But you can also see that because this line is kind of so far out, it is actually kind of pulling this trend line down. Okay, and if I were to get rid of it, this line would actually seem to fit better. It would kind of spring up. In fact, if I go ahead and delete these, you'll notice this line popped back up and the r squared increased from 0.7 to 0.85. Okay, and now I'll go ahead and undo that, and it goes back. Okay, but we're going to leave it for right now. Okay, but it looks like, especially if we got rid of this outlier, this is a pretty good predictor, and this is a pretty strong correlation between the data points. Okay, so now having said that, I want to have us calculate not r squared but r, this correlation between it. So in H3, I'm going to call it, I'm going to say correlation. Like this is our r. I'll go ahead and slide that. Notice as I make H wider, it actually increases the size of my chart. Okay, and so to do it, we're going to use the correlation function, or it's actually Correl. They abbreviate it. So I'm going to say it's equal to Correl. Okay, and it's going to say array 1 and array 2. And those are my just two sets of data points. And with correlation, it actually doesn't matter which I do, as long as one of them is square footage and one of them is monthly rent. So I'm going to do square footage first because it's in column D. So I'm going to go from D2, Control Shift down arrow, to D41. Okay, and then I'm going to hit comma, and now it says, okay, what's the second group of data points? And this one we want to do rent. So again, I'm going to do E2, E is an echo, Control Shift down. Okay, so I've got D2 to D41 and E2 to E41. That's and it's calculating the correlation for me. Okay, and you should get 0.83925, which is this is our correlation row, or R, the correlation coefficient that we talked about right here. This is how they calculated that line, and this is how we let Excel do the work for us. I don't need you to memorize a formula in this class. You will learn it in your statistics class, but that is what we're doing. And then now what I want you to show you is then this. So this is R. I'm gonna put R, and then I'm gonna put R squared, which I'm trying to calculate is this guy right here. And it turns out this is R, and this is r squared. So all I have to do is square the number that's in I3. So I'm going to say is equal to I3, and the way you square something in Excel is you do the caret, which is above the 6, times 2. I'm raising it to the power of 2. Okay, and if I make these 4 decimal places, that 0.7043 is that 0.7043. Okay, so I'm going to go ahead and just type in. This is the correlation coefficient, R. And if I put it within parentheses, Excel's going to try and make that a trademark sign. Okay, and then this is my R squared, and I'm going to say which is the square of the correlation coefficient. Okay. Now, this might seem like, why do we care? What is this telling us? So what I want you to do is I'm going to explain now, because we don't care about this other than I want you to be able to take information away from it. So I want to explain what our regression equation and how to interpret this R squared. Okay. So I'm going to go ahead and I might make this a little bit smaller. I'm going to go ahead and insert a text box here. So I went up to home. Next to home, I went to insert. All the way over here to the right, I'm going to choose a text box. Okay. And I'm just going to go ahead and pick a color. Probably that. And then I'll pick a shape outline. So the color I chose was like this one right there. Okay. And now what I want you to do is I'm going to type, and then you just pause and type in. But I want to explain everything that's going on in this chart. So I want to first explain this R squared. So I'm going to go ahead and type in the R squared is equal to 0.7043. Okay. And I'm going to explain it within like what it means with our square footage example here, and then I'll explain it more generally. So let's say that 0.7043, which means that the variation in square footage, the x-axis, or the x variable, explains 70.43% of the variation in rent. Okay, so that means if I know the square footage, and again, I've constrained it to be in a 6 block by 6 block area, right? So I'm sort of holding a bunch of other things constant, but 70% of the variation is explained by the rent, or I'm sorry, by the square footage. 30% is going to be explained by other things like, maybe how recently was it refurbished, how nice is the furniture, are you sharing a bathroom, does it have a washer dryer unit inside, or is there a laundromat in the basement, that sort of thing. Okay. If I were to expand out the perimeter, it might be like how many blocks away are you from campus or from the train station or something like that. So then I'm going to say more generally, okay, R squared tells us how much of the variation in the y variable, which is also called the outcome variable or the dependent variable, is explained by variation in our x variables, which are the predictor or independent. They're called predictor variables or independent variables. Okay. Right now we just have one, and in this class we're just going to do a single regression, but you can do multiple regression, which has, I can use bedrooms, bathrooms, and square footage to predict the rent. Okay. So the R squared of 0.7043 means that variation in square footage explains about 70.43% of the variation in rent. So it could only explain up to 100%. So 70% is great. More generally, in other cases, like if we were to run this again, it's how much of the variation in our x variable, like square footage, or our predictor variables, how much of the variation in the outcome variable does it explain? So in our next one, we would want to see like how much does education and experience explain your wage, like how much money you're making, right? So with the idea being that the longer you've worked at the company, the more you make. Okay, so let me write down, I want to explain this equation right up here, and I'm going to rewrite it just slightly. So I'm going to say y is equal to 512.98 plus 0.552x is our regression equation. Right? This is like y is equal to mx plus b that you learned in your algebra class or calculus class. Okay, this is called, what we're running right now is called a linear regression. I'm just going to put it down so you have these terms in case you hear them. Or OLS regression, where OLS is equal to, they call it ordinary least squares. I'll capitalize the O. And as I mentioned before, it is the line of best fit. Okay? It minimizes the distance from all these dots. Okay? Now, if we want to go more generally, what we're going to say is, if I plug in our particular variables, we're going to say rent is equal to $512.98 plus 0.552 times square footage. Okay, so in other words, for each additional square foot, so our x variable right here, we would predict rent to increase by 55.2 cents. Okay, and that's because we've got this in actual square footage, and we don't normally think about, hey, this one has 800 square feet and this one has 801. Okay, but so I'm going to type that out. I'm going to say, in other words, for each additional square foot, we would predict rent would increase by, and I'm going to round it to 55 cents right here, or 55.2 cents if that makes a difference. Okay, now I'm going to now say what that also would mean is, for a 100 square foot increase, we would predict rent would increase by $55.20. Okay, so, and if it were a 10 square foot, I'd expect it to be $5.52. And if it were 200 square feet, it would be 2 times 55.2, right? So it'd be $110. Okay, so, and that's because this is linear. This is a straight line, so we can kind of extrapolate. Okay, now, how do we think about this y-intercept here, this 512.98? Okay, so technically in this, the y-intercept is our predicted value if the x were set to 0. And in a lot of regressions, that doesn't make any sense because, like, I don't know what a apartment with 0 square footage is. Okay, but let me show what it is technically and then how we might think about it elsewhere. If I right-click on this line again, this trend line, and now I'm going to say Format Trend Line, so I can change the color and stuff. But if you go over here, and you may need to scroll down, you'll notice that it allows me to forecast forward and backward. Okay, and so what it'll do actually is extrapolate this line, or just extend the line forward or backward. And so if I type in backward, and it's a little weird because you type in a positive 500, not negative 500. And that's because our smallest apartment is about 500 square feet. It has now just extended that line. I think you saw that, right? It has extended that line backwards. So if I right-click on the trend line, Format Trend Line, and I just type in 500, okay, it has extrapolated that line back to where it crosses this vertical axis. Okay, now I'm going to now state it though is if this were a cost function, then we could think of this $512.98 as my fixed costs, right? My rent or something, even if I don't produce any units, and then this 0.552 as my variable cost. Like, how much does it cost me to produce one more unit? So let's go ahead and type that out. I'm going to say, if this were a cost function, okay, and so in your econ class, this would have looked something like the cost of producing quantity is equal to 512.98 plus 0.552 times quantity, okay, then the $512.98 would be my fixed costs. So costs that don't vary with output, like rent. Well, the rent I'm talking about is like if I were renting, like if I had a ice cream store, right, an ice cream stand, and I was renting the space, right, that kind of rent. Okay, so I'm just gonna say like my factory, but it's even if I produce 0 units, I still have to pay these fixed costs. Okay, and the 0.552 would be the variable cost. And I always use the example of ice cream cones, mainly because I love ice cream, but it's easy for people to understand. So I'm going to say, i.e., the cost of producing one more ice cream cone. Okay, it would be this guy. So we've explained the R squared, which is how well does it explain, or what percentage of the variation in rent do my variables explain? We've talked about what does it mean, how do we interpret this regression equation? Okay, and then if we were predicting something like a cost or a wage, you could imagine this would be your starting wage, and then this is how much people's salary or wage went up for each year that they worked, or each month that they worked. Okay, now, so then we could say, well, how could I use this to predict, right? Like, I don't want to just calculate these things. So you could say, what would I predict, or what would our forecast be for the monthly rent for a 800 square foot apartment? What about if it were 1,000 square feet? Okay, how could we use that? Well, we would just plug in 800 square feet or 1,000 square feet for X. So now when I do this, I always like to put in, I'm going to put in, so I'm doing this in row 42, but I'm going to put in, this is my y-intercept, and then this is my square footage. Okay, and then I'll put underneath this my predicted rent. Okay, so I want to have 3 things I'm going to input, and then it's going to tell me, it's going to give me my predicted rent. So let's go ahead, I'm going to go ahead and label these as, I'm going to put in the y-intercept is 512.98. Okay, the square footage, I'm going to put in first this price per square foot, and I'm going to put in 0.552. And I'm going to actually keep it as 3 decimal places. Okay, and then right here I can put in like 800 square feet or 1,000. And then this is our predicted rent. So I'm going to make these 3 right here. Let's go ahead and make them, I don't know, yellow. Oh, that's kind of an obnoxious yellow. Let's go ahead and actually we'll go ahead and use these inputs. And this input right here. And then I'll just bold them. Okay, so I'm going to have 512 times 98, and then I've got 55.2 cents a square foot times 800 square feet. So this is going to equal this times this. And then my predicted rent is going to equal the intercept plus the square footage. Okay, so for 800 square feet, I would predict we would forecast $954.58. Okay, so the line which is where our line is going to be. That's our predicted value, which is pretty close to those dots. Okay. If I were to change this to 1,000 square feet, let me go ahead and slide that out. So if it does that, all that means is that your font is bigger than the cell can display. So you just go up, if that's column I just go here to that line between it and double click, and it'll auto fit that. Okay, so I can make this 1,000 square feet. In fact, I'm going to put a little that there. So that's 1,000. If it were 1,200 square feet, like I can put in whatever the square footage is, and as long as, now this is the key thing there though, as long as this linear relationship holds, right? And so that's why we always want to plot this as a scatter plot. Okay. Okay, so let's do one last thing. Okay, so let's go ahead. I'm going to scroll over. Oh, let's ignore, we won't do the multiple variables. But let's do number 3 here, which is, let's go ahead and run this as, what we want to do now is, the reason I had you put in the Data Analysis Toolpak is we can actually run a regression with, well, this is a regression, but let me show you how to do it using Excel's Data Analysis Toolpak. Okay, and then I'll show you how we could do it with bedrooms, bathroom, like with more than one predictor variable. Okay, so let's go ahead and go up here to data analysis. Okay, and this is what the Data Analysis Toolpak is. So it allows us to run ANOVA, correlation, descriptive statistics, moving averages, regression, t-tests, and so on. What we want to do is we're going to use this to run a regression. Okay, so when I click on that, I've done regression. So the Y range is what is on my Y axis here, which is monthly rent, and I'm going to include the header in this. So I'm going to put in from A1, Control Shift down to A41. And if it doesn't let you do, sometimes it won't let me do that Control Shift down. So I'm going to go from rent, and I can just slide it as well. Okay, and then the X range is going to be the square footage, and I'm going to include the label here as well. Okay, so I'm going to go from, oops, now the X range, I'm going to click and put the square footage, Control Shift down arrow. Okay, now then you have to just click, I'm going to put it on a new worksheet, but you have to click these labels. If you don't, it's going to throw an error that says, hey, you've got text in there. So if you don't, it's going to throw this error and say regression input range contains non-numeric data. Now, why does it not automatically correct? I don't know, but it doesn't. Okay, so now I'm going to click the labels, hit OK. Okay, and it is thrown out or put down. Okay, this is a regression. So I've got my coefficient. I'm going to abbreviate this as SE for standard error. We've got p-values and so on. But this is our 0.552, like how much the increment for each additional square foot. This is where the 512.98 comes from. Okay, this is the R squared. I'm going to go ahead and just put it in here as, I'm going to put more colors. I like this yellow right there. Oops, either 1 or 2. Okay. So this right here is our correlation coefficient. Okay, this is our R squared. I'm just going to type it out as R squared. Okay, and then this is these two right here this is our regression equation. Okay, and because it's a single variable, it's telling us the same thing that we saw here. Now, if we do more variables, so if I did bedrooms, bathrooms, and square footage, it wouldn't. Now this is now giving me more information, and I can't display that on a two-dimensional chart. Okay, so that's how we do a regression in Excel. This is how we do equation, and then this is how they come up with those correlation lines. Okay, so with that, I've asked now 5 questions on the quiz, and then you will, of course, upload and submit this. Please make sure to include the chart and then your text box here with your notes, and then this little calculator area down here showing how you calculated the predicted rent. Okay? And with that, that's where we'll stop. Good luck.